Okay, in this video, we're taking the data that we just did from the stem and leaf plot. I've transferred it up. This is the ordered stem and leaf plot. I didn't have the key here, but the key is 3. There's your key. 3-2 equals 32. So this is already ordered. It's from least to greatest. And now we're going to take this data and make it into a box and whisker plot. A box and whisker plot is basically can be used when you want to separate the data or look at the data or interpret the data based on quartiles. The way, if all the data points are divided into fourths, what's the lower fourth? Next, midpoint to halfway between the mid and the bottom, and then midpoint to halfway between the mid and the top, and then the upper quartile. So you have anyway, you have the data and how it's distributed between those quartiles. So first step again, we need to order the data from least to greatest by making a list or ordered stem and leaf plot. So I already have the ordered stem and leaf plot, so we've done that. Now we're going to find the median, upper and lower extremes, and the upper and lower quartiles. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 numbers in this data set. And so the median of an odd number, 15 is an odd number, the median is going to be, you could do it like this, go over 1 and 2, and so on. But I know that the middle point, if the number is total, there's 15 numbers, the middle point is going to be the 8th number. So let's see, 1, 2, 3, 4, 5, 6, 7. This should be my middle number or the median. And I can just double check that because there's 1, 2, 3, 4, 5, 6, 7 numbers before that, and 1, 2, 3, 4, 5, 6, 7 numbers after that. And so I can determine, again, I determine my median, I'll write it over here, is, that number is 18, right? The stem was 1 and that's 8. So now that I have that, now I want to find the upper and lower quartiles are the numbers, the number between the median and the upper number. Well, let me back up. The lower extreme and the upper extreme, the smallest number is the lower extreme. So in this case, my lower extreme is 3. My upper extreme, you won't see these abbreviations anywhere, I just made that up, is 32. Okay, I'm just doing it for simplicity's sake. Now I want my lower quartile, and you might see this as LQ and UQ. So lower quartile is going to be halfway between the lower extreme and the median. So now in this case, since I had an odd number in my total data set, I'm not going to use this 8. I'm not going to use this 8. Just going to use the numbers between the lower extreme and here, not including this this 8, which was the median. So there's 1, 2, 3, 4, 5, 6, 7 numbers. Then I know that the fourth number, oops, that's not the fourth number. 1, 2, 3, 4. My fourth number should be the middle of those remaining numbers because there's 1, 2, 3 numbers before this number, and there's 1, 2, 3 numbers after this number. So my lower quartile is 11. And then my upper quartile is 1, 2, 3. The fourth number over here because there's 3 numbers before, and then 1, 2, 3 numbers after this number. So this is 25. That's going to be my upper quartile. Now, before I move on, that's how it works if you have a nice odd number here. Let's say, for example, I had, instead of 15 numbers, let's say I had 17 numbers. 17 numbers in my data set. Still an odd number, so I would take the middle number of the 17 numbers. It should be the 9th one over as I count across. That'll be median. Now, once I take that, I will have eight numbers before that median, right? And 8 numbers after that median. Hope you're following me here. If I had 17 total numbers and I found the 9th number was the middle one, then I would have 8 before that and 8 after that. Okay, now what I would do, since 8 is an even number, is I would have to find the 2, not including that middle number, I'd have to find the 2 in the middle. So I'd go up 1, 2, 3, 4 numbers, and then there'd be 1, 2, 3, 4 numbers after that. So those 2 middle numbers, I would take the mean of those 2 to find my lower quartile. And then again, if I had 17 numbers and there was 8 after the middle number, I'd find the mean between the middle 2 numbers. I hope that makes sense. And that would be my new lower quartile. Or I could take it one step further, and let's say I had 12 total numbers in my data set. If I had 12 total numbers in my data set that I don't have one number for the median, I have 2 because 6 before and 6 after, there's 2 middle numbers. So again, I take that median, or the mean of those 2 middle numbers, the mean average of those 2 middle numbers, that would be my median. And then with the remaining, again, the 6 before, I would take the middle 2 and find that the mean of those 2 middle numbers. And then with the 6 in the upper half, I would take the middle 2 numbers of there and then find the mean of those 2. That would be my upper quartile. So anyway, the point is that if it doesn't work out to be an exactly odd number, then you need to take the 2 middle ones and find the mean of those 2. In this case, it worked out, and so we're all set. Now all we need to do is plot the data. Now, I'm going to make a number line. Okay, and on my number line, again, my smallest number is 3, so I'm going to start my number line at 0. That makes sense, right? And then my highest number is 32, so, of course, using a ruler, and you'll want to be accurate about this. You want the spacing evenly, make a nice number line. So what I'm going to do is I'm going to say, I'm going to just say 10 inches. There's 10, 20, 30. I suppose I could go to 40 up. It's not really necessary. Maybe 35 is enough. Okay, but this is 10, 20, 30. You'll notice they're all spaced out evenly. Okay, that's important. Okay, now my lower extreme is 3. Okay, and then the lower extreme you're going to represent that with a dot. Okay, and then my upper extreme is 32. Okay, I'm going to represent that with a dot. Now, my median is 18. So at 18, I'm going to draw a line. This is where we get the box and whiskers from. And then my lower quartile was 11. So at 11, I'm going to draw another line. Okay? Then my upper quartile was 25. So at 25, I'm going to draw a line. So in other words, the lower and upper extreme get a dot, and the upper and lower quartile and the median get a line. And then you connect those to make the box. Man, it's such a glare. Sorry about that. And then here's your whiskers. Okay, so this tells us how the data is distributed. So from this, it looks like it's pretty evenly spaced out. We said the scenario was this is commutes to school, so half Now we can see these in terms of have to, right? Half of the students have between an 11 and 25-minute commute to school. This was the data that we used. We said these numbers represented minutes that it takes to get to school, okay? And quite a glare, huh? And half of the students are between 3 minutes and 18 minutes, and half the students are between 18 and 32 minutes. And then we can say a fourth of the students are between 3 and 11 minutes, and a fourth of the students are between 25 and 32 minutes. And so we can use this data again to kind of make some generalizations. If it was all scrunched up over here, then we could see that there's a kind of some exceptions that's skewing the data. But this is a way to partition or separate the data based on, bottom fourth, next fourth, and so on. So I hope that is clear. And again, I know that the averaging things, and if the numbers turn out to be even numbers, is a little confusing, or I should say use the term mean, taking the mean if there's two middle ones. But hopefully that's at least something to get you started. And thank you again for watching.